Namaste everyone. By the way, I am Gaphor Salwa. So for today's video, we tackle the activity 4 factor that affect the solubility in nature of the solute and solvent. So my objectives is differentiate the solubility from the solute and solvent, and to understand how temperature and pressure and the presence of the other solutes affect the solubility of solute and solvent. So solubility in solute solvent. What is solubility? Solubility is the ability of the solid and liquid or gaseous a chemical substance to dissolve in a solvent. Solute is the substance that added to a solvent from the solution. In a homogeneous mixture, the solute completely dissolves in another substance, and the solute is uniformly distributed throughout the solution. Solvent is a substance that dissolves and solute particles during the formation of the solution. Most solvents are in a liquid state, but some solvents may be in the gas or solid state. So factor that affect solubility: temperature. The solubility of both solid and gases affected by temperature. It has direct impact on a substance solubility. The amount of solute that can be dissolved in a solvent is also affected by temperature. Pressure: only the solubility of gases is affected by pressure. It has effect on the solubility of a gases, a liquid, but not on the solubility of a solid in a liquid. Change is pressure have almost no effect on the solubility of solid and liquid solute. The nature of the solute and solvent. Solubility of a solute in a solvent purely depend on the nature of the solute and solvent. A polar solute dissolved in a polar solvent. So the factor that affect the rate of the solution: size of the particles is dissolved. It only occurs on the particle surface as the overall surface area of the solute. Particle arises that solute dissolves more quickly. So when stirring liquid or solid solute, new portion of the solvent come into the contact with the solute. As a result, stirring helps the solute dissolve more quickly. Temperature: when it comes to liquid and solid solute, increase in a temperature increases not just the amount of solute that dissolve, but also the rate at which dissolve in the case of gases. The opposite is true as temperature increases, so the solubility and rate of solution decreases. So here's the video. We mix the cooking oil and water, cooking oil and gasoline, cooking oil and alcohol. So we mix it together, the cooking oil and water. Next is the cooking oil, gasoline. Next is the cooking oil and alcohol. We shake. So my observation: cooking oil and water, the two do not mix when you pour everything into the cup of water. Oil will be always float on top of the water because it has a lower viscosity than water, as I illustrate in this video, generating an oily surface layer. So next, the second is the cooking oil with alcohol. As a result, a drop of alcohol floats on the top of drop of oil because it is a lighter than less dense. This means that when you mix the two together, the oil settles to the bottom and the alcohol raised to the top. Next, the third one is cooking oil and gasoline. Many distant nonpolar compounds can be found in the gasoline. Hexane, heptane, and octane are some examples. Gasoline is an excellent solvent for oil and grease. Next is Zonrox plus water, Zonrox with gasoline, Zonrox in plus alcohol. So we mix it and let's observe. Zonrox, and alcohol. We mix it together. So my observation, Zonrox plus water, you can create a high, intermediate, or low level desiccant of by mixing various amount of bleach with water. They disintegrate nicely as can be seen. So Zonrox in gasoline. When the disinfectant and alcohol are combined together, we can observe that they dissolve well. So third one is the Zonrox in alcohol. The Zonrox and gasoline not does not dissolve. So next is ink. We mix the water. Second, ink with gasoline. Third one is ink and alcohol. First is the ink and gasoline. Second is the ink and alcohol. The third one is ink and water. So we mix it together. So my observation for this ink and water, it is note that the ink and water dissolve nicely after shaking the container containing them. Uh, Second is ink and alcohol. We can see that ink and alcohol dissolve will when mixed together. Ink and gasoline. When the two are mixed, the ink and gasoline do not dissolve the whole. So my generalizations, the interactions between the solute and the solvent is critical when determining solubility. Strong, the solute and solvent interaction are associated with the higher solubility, whereas weak solute solvent attractions are associated with the lower solubility. In contrast, the polar solute dissolve better the polar solvent, while nonpolar solute dissolve best in the nonpolar polar solvent. So that's all, and thank you for watching.